Hey everyone, today we're going to learn how to retrieve a sorted data sequence in a binary search tree. So let's get started. And if you want to see this PPT for yourself, you can download it from the link in the description below. So what is a sorted sequence? A sorted sequence refers to the order in which the nodes are visited in a binary search tree. And there are generally three types of sorted sequences. First is the in-order sequence, then is the pre-order sequence, then is the post-order sequence. There is an additional sequence that is the level order sorted sequence. But in this video, we're just gonna talk about in-order, pre-order, and post-order sorted sequences. In an in-order data sequence, traversal occurs in an ascending order. That means it starts from the node which has the lowest value and ends at the node which has the highest value. And the method in which the nodes are visited is it starts from left, then goes to the parent node, that means the root node, and goes to the right node. Here we have an example. Figure 5, as you can see, is a binary search tree. Okay, figure 5 is a binary search tree. In the second point, we learned the traversal occurs from left, then root, then right. So it must start from the leftmost node and end at the rightmost node. Okay, it must start in the figure. If you see, it must start from 1 and end at 16. So in an in-order data sequence, what is an in-order data sequence? The data are arranged in ascending order. So it will be arranged in ascending order. So 1 through 16 is in ascending order. So this is an in-order data sequence. This binary search tree is now sorted in in-order data sequence. As you can see, it satisfies the first point. That means the data is sorted in ascending order. It's sorted from 1 through 16. That means it is sorted in ascending order. So next is pre-order data sequence. Here the traversal starts from the root node. And how the nodes are visited? First, the root node or the parent node is visited, then the left node, then the right node. So here we have an example, figure 5. It is the same binary search tree that we used earlier. So figure 5 is a binary search tree, and following the second point, the traversal must start from the root node and must end at the rightmost node. That means the traversal must start from 10 and end at 16. So in the pre-order data sequence, it will be this, right? The pre-order data sequence will be this. It might be a bit difficult to understand right now how the sequence is forming, but I'm going to explain it later with an example. All the three sequences, in order, pre-order, post-order, all three sequences with an example. Now we have the post-order data sequence. How does the traversal work? So here the last node that we will be visiting will be the root node. That means the first node of the binary tree. So here the sequence will start from the left node, then will go to the right node and end at the root node or the parent node. So here we have an example. It's the same binary search tree that we used. Okay, figure 5 is the binary search tree, and if we follow the second point, that means the traversal will start from the leftmost node and will end at the root node. That means the traversal will start from 1 and will end at 10. As you can see, the post-order sequence, it starts from 1, ends at 10. And how are we getting this? I'm gonna come to it later in the next slide with an example, and it will be very easy, very clear for you. So here we have a question. So this is a binary search tree. We have to find in-order, pre-order, and post-order sequences of this binary search tree. So I've broken this entire problem into 4 simple steps which you need to follow to get the entire answer. Okay, let's get started. First, step 1, break the tree and write every single node along with their child nodes. Okay, there's an important point, that's why I've given an asterisk here, red asterisk. We have to write and draw, both write and draw only the nodes with one or more child nodes. Okay, we won't draw or write the nodes with no child nodes. Okay, we will only write those which will have at least one child. Okay, from here, so if you see in the question, 1 does not have a child node. Okay, so we will not write 1. 4 does not have a child node, we will not write 4. 7 does not have a child node, we will not write 7. 13 does not have a child node, we will not write 13. But the other 5 we will write because they have at least one child node. So 8, 3, 6, 10, 14 are the nodes which have only at least one child node, and we need to draw those nodes. So node 8, as you can see, A I have drawn along with the child nodes. What did I write? Write and draw only the nodes with one or more child nodes, and you have to draw every single node along with the child node. That means for node 8 we have to write the child nodes as well. That means 8, 3, 10. Node, then 3 is a node, we drew 3, 3, 1, 6. 6 is a node, we wrote 6, 6, 4, 7. 10 is a node, we wrote we drew 10. 10 and 14, 14 is a node, we drew 14. 14 and 13. Before starting, you need to know that the sequence, you need to start from the top. Always you need to start from the topmost element. That means you need to start from the root element. That is, here you need to start the sequence from 8. So here the images that we drew will come in handy here. So 8 we got is a node, right, with at least one child node. So we will go to the image of 8. So 8 will follow the in order sequence, which is left, root, right. First we will consider left, right? 3. Now 3, there is a problem. 3 is a node. So we will go to the image of 3. So here 3 will follow the in order sequence, left, root, right. Left, 1. But 1 is not a node, as we saw. What did we write? 8, 3, 6, 10 and 14 are the nodes. 1 is not a node, so we will write 1. Okay, because it's following the in order sequence, left will come first. And in left, as you can see in B, 1 is in the left, so we write 1. Root, what is the root? In B, 3 is the root, we write 3. Then right, 6. Now there is a problem. 6 is a node, so we will go to the image of 6, which is C. Now 6 will follow the in order sequence. First we will write left is 4, we wrote 4. 6, then root, which is 6, we wrote 6. Then a right, which is 7, we wrote 7. Now if you see carefully, we got all the elements in the left side of 8. Go to the question, we got all the elements in the left side of 8. That means if you go in A, the left side of 8 is complete now. Okay, the entire left side of 8 is complete, and in the in order sequence, after left side what comes? The root, right? Then we will write the root of this of A is 8, so we wrote 8. Then go to right. What is in the right of 8? 10. But there is a problem. 10 is a node. Okay, so we will go to the image of 10, which is D. Now 10 will follow the in order sequence, which is left, root, right. There is no left node, we won't consider the left node now. We will go to the root node. What is the root node? 10 is the root node. We wrote 10. Now right node, what is the right node? 14 is the right node, but there is a problem. 14 is a root node. 14 is a node. That means we will go to the image of 14, which is E. Now we will go to the image of 14, which is E. Now E will follow the in order sequence, which is left, root, right. Left, what is left? 13 is left, we wrote 13. What is root? 14. 14 is the root, we wrote 14. There is no right node, so it's complete now. There's no write down. We need to write. We don't need to write. Now if you see carefully, we got all the right elements of 8. Okay, so we got all the left elements of 8, we got 8 itself, and we got all the right elements of 8. Okay, so it followed the in order sequence. That means it completed the left first, then it came to 8, which is the root, then it went to right, which is the rightmost node, right? Then it went to right, first left, then root, then right. That means the in order sequence is now complete, and we got the answer of the first question. Now we will follow step 3. In step 3, we will find the pre-order sequence. Okay, in the same way we did the in order sequence. First, what did we learn in the pre-order sequence? It will follow traversal from root to left, then right. And from step 1 we got 8, 3, 6, 10 and 14 are the nodes, right? And always we will start from the top, which is 8. We'll start from 8, and 8 is a node. That means we'll go to the image of 8, which is A. We went to image of 8, which is A. So it will follow the pre-order sequence, which is root, left, right. What is the root of A? 8 is the root of A. We wrote A. Then we wrote 8. Then go to left. We went to 3. But there's a problem here. Now 3 is a node. We will go to the image of 3 now, which is B. Now in B we will follow the pre-order sequence again, which is root, left, right. Root, what is root in B? 3 is the root in B. We wrote 3. Left, 1, and left of B is 1, so we wrote 1. Then right in B is 6, right? But there is a problem. 6 is a root. So we will go to the image of 6, which is C. Now in C we will follow the pre-order sequence again. So what will happen in the pre-order sequence? First we will get root. What is the root in C? 6 is the root in C. Then left, what is left? 4 is left. Then right, what is right in C? 7 is right in C, right? 7 is right, 4 is the left. So we wrote 4 first. First we wrote root, then we wrote the left, which is 4, then we wrote 7, which is right. Now if you see carefully, we got in our original image, what we got? First we got the root, right? If you follow the pre-order sequence, we got the root first, which is 8. As you can see, first we got 8. Then after that we got 5 elements, right? We got 3, 1, 6, 4, 7, which are all the left elements, of the tree. That means we have completed the first part, which is we got root, then we got left, then we need right. Okay, so in the right of 8, what is in the right of 8? 10 is in the right of 8, but 10 is a node. So we will go to the image of 10, which is D. Now 10 will follow the pre-order sequence, which is root, left, right. What is root in D? 10 is the root in D. We wrote 10. Left, there's no left, so we won't write left. Then right, which is 14, but 14 is a node, so we'll go to the image of 14, which is E. Now E will follow the same sequence, pre-order sequence, root, left, right. What is in the root? 14 is in the root, so we wrote 14. Right, left 13, there is 13 in the left. Right, there's no right. So if you see carefully, we got all the right elements as well in the entire tree. We got all the right elements. Okay, so this is complete now. We got all the left elements. First we got the root element, then we got all the left elements, then we got the right element. That means the pre-order sequence, what is the pre-order sequence? Root, left, right. We got root first, then we got all the left elements, then we got all the right elements. That means the pre-order sequence is now complete, and we got the second question's solution. Now we have step 4, which is the last step. We need to find post-order data sequence. What is the post-order data sequence? As we learned in the post-order data sequence, traversal occurs from left, then goes to right, then at the end goes to root. Okay, And from step 1, what did we get? 8, 3, 6, 10, 14 are the nodes of the binary search tree, right? So let's start. First, always start from the top, which is 8. Let's start from the top. 8 is a node. Let's go to the image of 8, which is A. A is the image of 8, so we will start from A. A will follow the post order sequence. What is the post order sequence? Left, right, root. What is in the left of 8? 3 is in the left of 8. But there is a problem. 3 is a node. We will go to the image of 3 now. In the image of 3 we go. B is the image of 3. So B will follow the post order sequence. So if we follow the post order sequence in B, first comes left, which is 1. We wrote 1. Then comes B, which is 6. But 6 is a node, right? 6 is a node, as we got from step 1. So we will go to the image of 6, which is C. Now C will follow the post order sequence again, which is left, right, root. What is in the left of C? 4 is in the left of C. Then what is in the right of C? 7 is in the right of C. We wrote 7. And root, what is in the root of C? 6 is the root of C. So now, as we have completed C, we will trace back, right? So we have completed the right node of 3, right? We completed first the left node of 3, which is 1. We wrote 1. Then we completed the right node of 3, which was 6. Then we went to C. We completed 6. So we completed 6, right? We completed left node of 3 and we completed right node of 3. Now we go to the root node of 3, which is 3, right? Now we wrote 3. Now if you see carefully, we got all the left elements. We completed the left node of 8. Okay, all the left nodes. Okay, we completed all the left side of 8. So what if you see in the question, we got all of these, right? All these 5 numbers, right? We got all these 5 numbers in the sequence. So we completed the left of 8. That means in the post order sequence we got the left. Now we go to right. Okay, right of 8 is 10, right? Right of 8 is 10, but 10 is a node. We will go to the image of 10. Okay, we went to the image of 10, which is D. Now D will follow the post order sequences. Left, right, root. Left, there is nothing, we won't consider it. Right, that is 14, but 14 is a node. We will go to the image of 14, which is E. E is the image of 14. So E will follow the post order sequence, right? Left, right, root. Left, there is 13, so we wrote 13. Right, there is nothing, so we are writing nothing. So and root, there is 14, so we write 14. Okay, root of E is 14, we write 14 now. Then we trace back. We did the right side of D, there was no left. We went to right side of D. Now we will go to the root of D, right? The post order sequence comes from left, right, then root. So we will get the root of D, which is 10. We wrote 10 next. Then if you see carefully, we got all the right elements of 8 now. We got all the right elements of 8 in the sequence. That means first we got all the left elements, then we got all the right elements. What does post order follow? It follows first left nodes, then a right node, then the root node, right? We got the left, then we got the right. Now the root node is left, so we will write 8, which was the root node, and we got the last answer, which is the post order sequence. So here we learned how to sequentially write a binary search tree in the easiest way possible.